Greatest common factors. How do they work? What are they? Here we go. You need to be able to see what they have in common, right? What are they divisible by is kind of what I'm really asking here. Well, what do these two numbers have in common? 2, right? I agree with 1, but technically everything's going to have 1 in common. You can divide anything by 1, so that doesn't count, although that is true. So these two numbers have a 2 in common. This is too easy. What do these numbers have in common?
2.
2. They're both divisible by 2. Are they both divisible by 3?
No.
Is he?
Yeah.
That's not both of them. That's the whole idea, is you're looking for what they both have in common, okay? Here we go again. Ooh, wow. What do they have in common?
2.
This is very boring. Okay.
Yeah, good job.
I'm doing this on purpose, I promise. I thought this out beforehand. Okay, curveball now. What do these have in common? X. That's very awkward. You have an X in common.
Oh, okay.
And you have an X in common?
Ta-da.
I thought it would be like a funny high school relationship joke, but
Ha,
oh,
ha, ha,
can't
ha,
see it.
ha.
And I laughed inside when I purposely realized, like, ha ha, I'm gonna make, okay. They have an X in common. Cool, nice. Next one. What do these have in common?
X.
X. Cool, awesome, done. All right. Now, what do you do with this? You need to be able to first find what they have in common. That's the step we're gonna do for literally all of these. What do they have in common, okay? But you need to be able to factor out what they have in common and take out the greatest common factor. Divide it out, okay? So right here, we'll start off with, actually, no, we'll start off with this one, okay? They have a 2 in common, so I'm gonna divide by 2. So 2, now let's do this. 2x divided by 2 is just
X.
x, right? I divided by the 2. 2 divided by 2 is technically 1. You see the little ghost 1 there, but I'm not gonna write that because that's weird. 6, 2, what?
3.
Yes, so plus 3. Cool. That is the answer. Okay, now this should also make sense because you remember last unit, 2 times x plus 3. What would I do here if I distributed it? I'm multiplying now instead of dividing. 2 times x is 2x, right? And 2 times 3, and we're back. See what I'm saying? Okay, so last unit was distributing, multiplying things out, and now we're basically undoing that to get back to here. Okay, so it's a cycle, right? So we're gonna do that same thing now to these other ones, right? So I'm gonna factor out a 2, okay? Careful with this one, something weird happens. 6 divided by 2 is 3. What x? What about this?
It cancels out.
It cancels?
No, it's just
Nothing?
It's a 1.
It's a 1?
It's nothing because they just.
It's nothing.
Yeah, it's nothing.
If I leave it as nothing, right? Let's just say, and in fact, I'll even just literally just have nothing here. If I were to multiply it back out, would I get what I started with?
No,
See
you
what
put
I'm
a
saying?
1.
So 2 times 3x is 6x. 2 times 0 is 0?
No.
See the problem,
Yeah.
right? Yes, so you need a placeholder, is what I call it, a placeholder of 1, right? Because now 2 times 3x is 6x, 2 times 1 is 2. We full circle, we can loop it all around now. Another reason why that makes sense though, is 6 divided by 2 is 3. What's 2 divided by 2? 1, right? So yeah, and right here, 2 divided by 2 is 1x. So it's there. I just don't want y'all to think, oh, it's gone. It's, cancels, right? It's just 1. All right, so here now, same thing happens. 2 divided by 2 is just an x now. 2 divided by 2 is just a 1 now. Okay, see the idea? I'm trying to show you the placeholder thing here. All right, now here, curveball. Real quick, time out, hold up. What is 3x plus 5x? Are those like terms?
Yeah.
Yes, we did this last test as well.
8x.
Combine like terms, that's 8x. Cool? All right, cool. Now let's be super extra to use some more cool high school lingo. All right, so what do they have in common?
An x.
So I'm going to factor that out now. 3x, I'm dividing out an x. I'm taking away an x. I'm left with
A 3.
3.
You shot
right?
an X.
Right? 1x, I subtracted off away an x. And then I have plus 5x, take away an x, I'm left with
5.
5. Cool. What's 3 plus 5?
8.
So I have x times 8. What's x times 8?
Yeah.
Oh my God, it all works. Okay, now please do this. Like, oh, okay, but you get the idea. You see what it all works. All right. Now here they have an x in common. This is combining both concepts into one. They have an x in common. 2 divided by 1, the 2 just stays there. Did I mess with the 2?
No.
No, it's just a 1, okay? That's like one of the things we said at the very beginning. Everything has a 1 in common. So the 2 is just now 2. I took away that x, and then plus 1, please. Thank you. Yes, you need that placeholder there, right? Yes, because x times 1 is just x, right? So if you, there's no more x's. Now it's gone, and you lost the loop, right? So make sure you keep that placeholder there, just like we talked about here and here. Okay, cool. Now, the next level curveball here is this, okay? My analogy for this is if you're going out to eat with your friends and you and your 2 other friends, you've been working hard, you've been hard at work, you got like $20 in your pocket to go spend some food on. The other person, he's working hard too, he's got $20 in his pocket. This guy though, slacker, he has $2.
Slacker.
What's gonna happen when you go out to eat for the $2 guy?
He dies.
He's gonna be like, I'm gonna get some water. We're gonna go to Chili's. I'm gonna have can y'all order chips? All right, cool. And they'll just
a cup of ice.
a cup of ice and some chips for free, right? So you're not gonna go out to eat at a fancy place. You gotta dial things down for the cheapo and go to McDonald's or Taco Bell, right? So here's my question. Out of these x's, sorry, I got ahead of myself here. What do these numbers have in common? What does an 87 and a 2 have in common?
X.
What? Just the numbers.
Oh,
Does an 87 and a 2 have anything in common? If it takes you a while to think about that, first of all, we already said 1. 1 doesn't count. The only number here is 2. Like 2 is divisible by 2. Is this divisible by 2?
Nope.
No, because it's not even.
It's
little-
divisible.
yeah. So no, there's numbers that have nothing in common. What do they have in common though?
An X.
Now here's the careful part. They have an x in common. What's the most amount of x's that they all have in common that I could go take from?
5.
What's the most amount of x's? 5 x's? Does he have 5 x's to give if I went and tried to take 5 x's?
Yeah.
Yeah. Does he?
No, he has 2.
No, the cheapo, right? Okay. So out of all your friends, remember the analogy I just gave, the super terrible analogy, whatever?
Mm-hmm.
The $20, and $2. What's the most amount of money that they all have?
2.
2. See what I'm saying? The most amount of money they all have is only 2, right? Oh, what if he gets a paycheck and now he's at $7? What's the most amount they all have?
7.
Yes, but now this is the important part. What if he gets a paycheck? Cool. What's the most amount they all have?
7.
Still 7. See what I'm saying? So I'm looking at the most amount of that, like, cheapo person, the lowest person, okay? So, the most amount of x's that they all have in common is 2, okay? All right? He's holding this guy back, okay? So, 87 stays at 87 because they don't have any numbers in common. I have 2 x's. I take away 2 x's. I'm left with, no x's, 0 x's, right? So there's none. Just like here, I had an x, I took it away, gone. Had an x, took it away, gone. Right? I had 2 x's, took them both away, no x's, right? Here now, plus 2, I have 5 x's. I take away 2 x's,
3.
3 x's. That's the answer.
Wow.
Okay, that's how this works. So, this also should make sense too. With the numbers, what operation am I doing with the numbers? What operation am I doing with a 6 and the 2 and I got a 3? What operation is that?
Division?
Division. I'm dividing the numbers. But what am I doing with the exponents?
You're subtracting.
Subtracting them. Okay, so make sure you keep that in mind. And here's my best example for that. And I got 2 more and we're done. Yeah. So I have a 10x to the 10th and a 15x to the 15th. How cute. I purposely did that. What do the numbers have in common though?
5.
The numbers have a 5 in common? Yes, they have a 5 in common. Awesome. What about the x's? What's the most amount of x's that they all have in common?
10.
10, okay? Because I'm going to be subtracting x's, right? If you said any number less than this, he could give more x's. If you said any number more than this, he could not, and he could, you know what I'm saying? So, okay. Now I'm going to factor that out. What am I doing with the big numbers?
You're dividing.
I'm dividing this. So 10 divided by 5
2.
is 2. Cool. 10 x's, take away 10 x's, I got no x's. See what I'm saying? Okay. Minus 15, or sorry, I shouldn't necessarily write that minus in there. Negative 15 divided by 5 is?
Minus 3.
Minus 3, right? Negative 3.
Yeah.
I have 15 x's. I subtract 10 x's. I have 5 x's.
Nice.
Okay, there you go. Now, the biggest thing with these, if you're any part of confused or I don't know, or this question might look the hardest, but this one you will learn the most from because it's like, oh, that's how it works. Okay, so I've purposely made this one look big and nasty more so than anything it is on your papers. So let's go through this and then we're done. What number-wise, numbers, what number do they all have in common?
2.
They do have a 2 in common, and I caught you. I baited you into that one. They all are divisible by 2.
10.
More though. Are they all divisible by 5?
Yeah.
Yes, they're all divisible. Keep going. Biggest,
5.
greater.
10.
10, right? You're trying to max it out, right? With the numbers, I'm dividing, and I'm trying to get the biggest number to divide with. Just like I'm trying to get the biggest number to subtract with for the exponents. Okay, so I have a 10 in common. Great. For the x's, do they have an x in common?
No.
Interesting. Do they have an x in common? We said no. What makes you say no? I see an x here, I see an x here, and I see an x here.
Oh, yeah.
They have an x in common, right? So they do have an x in common. They had one, they have, yes, they have an x in common. Are they the same x's across the board? No, I don't care about that. I'm looking for what they have in common, right? Now, what's the most amount of x's that they all have?
2.
I got 2, I got 10, I got 5. I'm about to go through here and take away x's. What's the most amount I could take away?
2.
2, yeah. Okay, I take away 2 from him, I take away 2 from him, I take away 2 from him, everybody's good, and I've maxed it out, okay? Y's, what's the most amount of y's I have? I got 100 y's, wow,
But you
100.
can only take away 2.
Oh, I can take away 2, yeah, ooh.
Oh, 1.
If I get here and tried to take away 2 from him, could you do that?
No.
No, and then you're negative exponent, and then it's weird, and then nope. We're not gonna get into that, that's algebra 2 thing, all right? So cool, that's all the amount of y's I could possibly take. Last one, z's.
Just 1.
Z's, what's the most amount of z's I could take?
Uno.
1? Do you see the problem?
There's no common Z's?
There's no other z's?
Yeah.
They do not have a z in common at all. I can't take away a z, right? This is what I'm saying everyone has in common. Everybody has this. I'm going to take it away from everybody. Everybody has this. I'm going to take it away from everybody. Does everyone have a z?
No.
No. So you can't say you can't. All right, cool. That is it. Okay? That's the biggest, most important thing you have to do. And at this point now, you're just doing division and subtraction all the way through here. Very basic stuff. 20 divided by 10, we have 2.
Z.
X squared, take away an x squared, I have no x's. Y squared, take away 1y, I have
1Y.
1y. Z, did I mess with the z's?
No.
No, so he still stays there. Z. Cool. Easy. Huh? 10 divided by 10 is 1. I guess if you really wanted to, you could write 1 right there as a placeholder. 10, or x to the power of 10, minus 2 x's. I'm left with
8.
8 x's. So I'm going to erase that 1, and I'm going to say x to the power of 8. Okay? Because I don't need a placeholder because it's there. Okay, yeah.
We have no Y's.
Y, I take away a y,
No Y.
no y's. And there's not even z's to mess with. Cool. Next one, last one. Negative 50 divided by 10, negative 5. I got 5 x's. I take away 2 x's. I have
3X.
3 x's. And the last one, just because I thought it'd be funny, 100 y's. Oh my God, Coach B, y to the power of 100. That's so hard. Oh my
99
God.
Y's.
I take away 1 y for a total of 99 y's.
Wow, you're so funny.
But a problem ain't one. Yes. Lincoln Park, or perfect timing.